Alright, so transformations using rotation. So just like translations and reflections, this won't change the shape. Okay? This will not change the shape. If you have an object and you shift it left or right, or you shift it up or down, it doesn't change the shape. It doesn't change the area. It doesn't change the congruency. Okay? Same thing with reflections, as you just noticed. Just because we reflected something didn't change its angles, it didn't change its area, okay? It remained the same, okay? Those were isometries, okay? This is also going to be an isometry. Just because you rotate something doesn't mean that it's changing its shape, okay? Where do you see things necessarily being rotated? Okay? Well, as you're looking at a map, sometimes on your phone, they usually set it up where north is straight up, but you can rotate it on your screen to make it different. But that's not changing the shape or anything, it's just looking at it from a different perspective, which might be beneficial if you're using kind of a GPS as to where you are, if you're looking at street level or something like that, and you want to know, you might not be facing north, or maybe you don't know which way north is, but you can at least arrange yourself with where you're at and what you're seeing on your screen. Okay, by rotating it to have you facing the same direction as you're holding your phone, basically. Okay, you're just rotating it. You're not really adjusting anything. Okay, but you're just rotating it, so it makes more sense to you. So, rotations definitely something that's that you can use. Okay, not necessarily with polygons, but we're just kind of using polygons to keep it simple, I guess. All right. So, transformations using rotations. So here's what we're going to do. We're going to take some object. I'll go ahead and I'll draw one up here. We'll say A is located here at 3, 1. We'll say B is located here at 6, 3. And we'll say that C is located at 2, 5. Okay, I'll give you a moment to go ahead and copy that shape down. Okay. So what we're going to do is we're going to rotate this object with respect to the origin. Okay? Now you can rotate it any number of degrees. Go ahead. You can rotate it any number of degrees, but we're just going to stick to 3 basic ones. A 90-degree rotation, a 180-degree rotation, and a 270-degree rotation. Right? So 90, 180, and 270 is how far we're going to rotate it. Why wouldn't we worry about rotating something 360 degrees? Yeah, now you won't have to move it. Or if I do tell you to rotate it 360 degrees, you go, ta-da, I did it. You just didn't see it. Okay? We went at 360 degrees, we put it right back where it started. Okay? So we're not really going to worry about that one. So a 90-degree rotation. Okay? All right. 90 degrees. What do you think of when you think of 90 degrees? Right angle. Okay? Half of 180, right? Okay? So a 90-degree rotation means I'm going to take this point and I'm going to rotate it 90 degrees with respect to the origin. Okay? Well, how do you do that? Well, what I like to think is that basically, I'll use the end of this. Okay? Basically, this point is on a string. Okay? And one part of that string is attached to that point, and the other part of the string is attached to the origin. So right about like this. Okay? My finger that's on the origin is going to stay put. Okay? But I'm going to rotate the rest of the string 90 degrees. So it's going to end up about right there. I just rotated that 90 degrees. Okay? I'll show you. So it's like, here was the string, right? I took that string and I rotated it 90 degrees. See how that makes a 90-degree angle right there? Okay? So notice, where does this point end up? This point 3, 1, where did it end up after a 90-degree rotation? Negative 1, 3. So, let's think about this. So for a 90-degree rotation, you can take whatever xy value they give you, so like 3, 1 for instance, and we rotate it 90 degrees, what will it map to?
It's opposite reciprocal.
So 3, 1 became negative 1, 3. So what could I say xy maps to? Who can see it? Negative y, right? Because this is my x value, this is my y, right? This is my starting, this is my x, this is my y. It became negative y, comma, x. Very good. Right? Negative y, comma, x. That's how you can do 90-degree rotations if you want to do it using coordinates. I really don't, okay? I really don't use coordinates myself, okay? But if you want to write down a rule for a 90-degree rotation, you certainly can. Okay? Honestly, here's what I think is easiest. Okay? So when I'm looking at this right now, okay, I'm looking at this and I see point A, it's located at 3, 1. Okay? What if, instead of looking at it like this, I turn my head 90 degrees and look at it this way? And think of this as my new origin. And then guess what I can do again? This was 3, 1, right? So go to 3, 1. Okay, see what I did there? Kind of goofy, alright? Maybe you don't have to turn your head, maybe you can just turn your paper, alright, so you don't get a cramp in your neck. Okay? But yeah, so I'm looking at it here, I'm just going to look at it, I'm going to turn my head 90 degrees, and I'm going to say, okay, well A was at 3, 1, so A prime, 3, 1, right there. Now that's really not the point 3, 1, you guys understand that, right?
Yeah.
But if you're looking at it this way, it kind of is similar to the point 3, 1. 6, 3. Okay, 6, 3. So if I want to find my new point B, my new B prime, I look at it here and go 1, 2, 3, 4, 5, 6, 1, 2, 3. So right there. There's my new point B prime. And then C was at 2, 5, so 1, 2, 1, 2, 3, 4, 5. There's my new point C prime. Alright? So there's a 90-degree rotation that just took place. There's a 90-degree rotation that just took place. So I kind of gave you two ways to do this. You could kind of memorize the rule, how the x and y switch spots and the y becomes negative. But that's going to be tough to remember, I think. But if you can do it, go for it. Or just kind of turn your paper 90 degrees and plot the exact same coordinates as if you were looking at it sideways. That's what I think is easiest. Okay? But you should see a connection, alright? So C prime now is located at negative 5, 2. B prime is located at negative 3, 6. So you see how we still have the same values in there, it's just the y values became negative and moved to the first spot, and then the x value became the y spot. Everybody okay with this? Okay, so that was a 90-degree rotation. 180 and 270 are going to be very similar. Okay?
You just keep going.
Yep, so 180-degree rotation is going to end up in what quadrant?
The third one.
The third quadrant. A 270-degree rotation will end up down here in the fourth quadrant. Okay?
You just keep turning your head.
Now, yeah. Don't try
We
to do
kind
that.
of
Okay?
that far.
Also, for the 270-degree rotation, instead of trying to turn your head 270 degrees, how about just turn it backwards 90 degrees?
Oh, that's a good one.
Okay? Yeah, I know. So instead of turning your head this way, now just turn your head this way. Right down there. Okay? I'm going to have you guys turning your heads or the paper, it's going to be...
We're gonna look like idiots on the
Yeah.
test.
Hey, get them right. We don't look like idiots, right? Okay? So, that's rotations. I'm going to give you the rules for the 180 and 270. A 180-degree rotation, your XY values, I believe, I gotta visually see it, but I think they switch spots and switch signs. And then on, no, I take that back, they don't switch spots, they just change. My fault, guys. Like I said, I don't usually do it that way, so I don't really have those memorized. They just switch signs. Okay? And then, that makes sense, I don't know why I wrote that wrong. And then for 270, I think they have to switch spots. And then you would, this would be negative x. Okay? So for a 270-degree rotation, this would be your mappings. Okay? But again, I think it's easy. You can memorize these. I think it's easier to just kind of turn your paper that way. What? No, because that was 90. That was 90. Okay? The new y value would become negative. That's why the negative is right here with the x. Okay?